Technology really is the key to astronaut training and the tools they use.
Right, but what about the research being conducted aboard the International Space Station?
Yeah, and the microgravity environment. How does that affect the astronauts working and living in space?
Well, for answers, we came here, to Building 9 at the Johnson Space Center.
What's unique about the research environment on the International Space Station?
How does zero gravity affect fluids in your body?
Describe the relationship between time and space and bone loss.
As the research manager for the ISS program here at the Johnson Space Center, it's my job to communicate with scientists who want to do research on board the space station.
I also work with the builders of the station to be sure it's both a well-equipped laboratory and observatory.
You see, the ISS is about exploration, human exploration.
It's the place where we will learn to live and work in space. It's where we'll establish a permanent human presence in space and advance human exploration of our solar system.
What kind of work will be conducted on the ISS?
Research. We will work on improving manufacturing processes, developing better health care, and researching tomorrow's products today. All this research will take place in the laboratories you saw earlier and in the unique, out-of-this-world environment of space. You see, the microgravity environment and the high vantage point for viewing Earth and the universe are unique. The permanent space station allows experiments to run for longer times than we used to on the space shuttle and gives scientists repeated access to these experiments. This research cannot be done on Earth.
Well, Dr. Bartow, it sounds like a microgravity environment will help scientists make new discoveries. But how will microgravity affect the people living on board the space station?
Great question, Jennifer. The human body reacts immediately and dramatically to the microgravity environment we feel when we go into orbit around the Earth.
Remember how you explained being on the station is like being in a state of free fall? It feels like there is no gravity. That's why we often call it zero G. One of the first reactions of the body to zero G is to push our internal fluids upward in our body. You see, on Earth, in 1G, our body works to push the fluids inside upward, so all the water, blood, and other fluids don't collect in your feet. When the body first experiences zero G, it continues to push the fluids up, as on Earth, but since there is no 1G pulling down anymore, the upper body and head ends up with too much fluid. If you've ever seen pictures of us in space on the first day, our faces are puffed up like chipmunks because of the extra fluid in our upper body. But the body quickly senses this condition and begins to move the fluids to different parts of the body. In about 2 or 3 days, we reach a new point of balance where our bodies have less fluid in our bloodstream than the average person on Earth. If you return to Earth's 1G in this state, you would probably faint. To counteract that, we fluid load just before returning to Earth. For instance, we drink at least 1 quart of water within 1 hour of returning, along with salt tablets, which keeps the water from passing directly to your bladder.
Wow. Well, how else does microgravity affect the human body?
Well, Van, a longer-term effect, which also begins immediately, is the loss of bone mass. When you lose bone mass, your bones become brittle and can break very easily. Anyway, only about 400 humans have flown in space, and only a fraction of them were tested carefully for bone loss. The numbers so far are startling. Healthy space travelers lose bone mass 10 times faster than people here on Earth. Whether in space for 1 week or 1 year, the rate of bone loss is about the same.
Let me show you how important math is when determining bone loss.
The percent of bone loss is a function of the length of time in space. L is the percent of bone loss, R is the rate of bone loss per month, and T is the time in space. So far, the data we've collected tells us that humans in space lose bone mass at a rate of 1% per month. The function L equals RT tells us that the longer you are in space, the more bone mass you lose. We have values of T up to 14 months, and the function appears linear. So far, we haven't had any astronauts in space for more than 14 months. This rate of bone loss could be a problem if we want to go on a 3-year trip to Mars and back. That trip would cause a bone mass loss of 36%. Our bones would be so brittle, any type of physical activity would be out of the question.
This is not good news. We wish the function would level off eventually with time, and further bone loss would stop.
So, how do you measure bone loss?
Well, we measure bone loss by conducting tests like X-rays on the crew, both before and after they fly.
Each person reacts differently to zero G. So we need to put the data from many astronauts all together and use statistics to predict the effect on future crew members.
We calculate means, medians, and standard deviation. Our statistics so far are not that good because we have data on so few people.
You see, when you average data from only a few people out of a large group, the result from those few people may not match the average of the larger group. However, if you collect data on hundreds of people, like ground-based medical research does, the average is more reliable and easier to predict. Because there are only a handful of good measurements on space flyers, our predicted average is less reliable. We just need to make many more measurements.
We'll also study why we lose our bone mass. Then maybe we can develop drugs to stop the effect. In fact, the National Institutes of Health is working with us on this research. So you see, research on ISS is not only about improving life in space, but also improving life here on Earth.
Well, thanks so much, Dr. Bartow.
You're very welcome.
Earlier in the program, Jennifer and I said you could see the ISS in the sky from your own backyard. Visit this website to see if the ISS will be flying over your city.